Okay, um, Calculus 3 students. Um, this is my first video for your class, and hopefully it will be a good video. I don't know if it's going to get any Academy Awards, but we'll see. Maybe my video will get nominated or something like that. Yes, you like these scary pumpkins? Very Halloweenish, right? Halloween is my favorite time of the year. Okay, so let's get going here. So let's take a look at your first homework. Let's see. Preview. Okay, let's minimize this. I'm going to move this over to the right side of the screen because I want to make room for Mathematica. Here we go. Okay, and I'm going to click on Mathematica. And new document. Okay. There we go. And let's see, 1 plus 1, shift enter, that's going to be 2. Okay, it looks fine, but you know what? I want to change my font and font colors a little bit. I'm going to change that stuff. Okay. Format, edit style sheet, input, and output. Let's start with input, format, show fonts. Let's make it 18 pixels, bold, and I happen to like Arial. I like Arial, and I like eggplant purple. Eggplant purple. Let's do the same thing for the output. We're going to make that bold, 18 pixels tall. Okay, I happen to like Arial. That's my favorite font. It doesn't have to be your favorite font. Use whatever font, use whatever color you want. Personalize it. Make the Mathematica notebook attractive to you because you're going to be looking at it. You're going to be using it. So it should be, the interface should be visually appealing to you because you're going to spend a lot of time this semester looking at it and working with it and using it, right? So blue, red, bold, not bold, small font, big font, knock yourselves out, personalize it according to your own artistic preferences, right? Okay, so I like eggplant purple, and let me see, are we good to go? I think we're good to go. And maybe we could even, well, no, we could do more, but I think for now that's enough. Okay, so I'm done with this window, and I'm done with this window. And we could move this over just a little bit. Okay. What is a position vector? That's the first question, okay? So a position vector has its tail at the origin and head at the point v1, v2. That should be option B. Oh, excuse me. Okay. Okay, good job. So next question. Given a position vector v, why are there infinitely many vectors equal to v? So their starting points could be different, okay? Their starting points could be different, but if their length and direction, if their magnitude and direction are the same, then they're considered equivalent. So 2 vectors are equal if they have the same magnitude and direction, and that's going to be option C. Okay, 2 vectors are equal if they have the same magnitude and direction. Option C, now be careful guys, it's option C in my version of the homework. In your version of the homework, It could be option A or B or D. I mean, these answers get shuffled around by Pearson's server. Okay, Pearson's server, which of course is sending information to Oakton, which in turn is sending information to your browser. Um, Pearson's server is going to shuffle these things around. So for me, the right answer is option C. For you, it could be A, B, it could be D. So just be careful. This is not monkey see, monkey do, okay? You got to be careful. Don't just copy my answers blindly because that's going to cause problems, okay? Check answer. Okay, next question. Okay, so if the u vector is equal to u1 comma u2 and the v vector is equal to v1 comma v2, how do you find u plus v? That's going to be pretty simple. That is simply u1, oh wait a minute, where are we here? Yeah, u1 plus v1, u2 plus v2, the answer should be C. Okay, next question. How do you compute the magnitude of v is equal to v1, v2? Well, that's easy. It's going to be v1 squared plus v2 squared, and then it's the square root of that sum. Okay, so that's going to be choice D, right? Okay, next question. How do you compute the magnitude of the vector that goes from P to Q from the coordinates of the points P and Q? Okay, so that's going to be Q1 minus P1 squared. Wait a second. Q1 minus P1 squared plus Q2 minus P2 squared, and I believe this is it. A, option A is the correct answer. Okay. How do you find a vector of length 10 in the direction of v is 3, negative 2? Well, first of all, you have to normalize this vector, and then you have to multiply it by 10. So if you normalize the vector, that means you divide each component by the length of the vector. So you divide v by its length and multiply the result by 10, which is option A. Okay, terrific. If a force of magnitude 92 is directed 45 degrees south of east, what are its components? So south of east means we're in quadrant number 4. Quadrant number 4 means x is positive, y is negative, right? So for example, well, you know what? I don't want to spend a lot of time drawing pictures right now because we're going to do that later on for another problem. But 45 degrees south of east means that the vector, it points 45 degrees below the positive x-axis. Okay? So that means that our vector could be 1, negative 1, right? Or it could be 100, negative 100, yes. Or it could be, 200, negative 200. I mean, it doesn't really matter what numbers you pick. You just have to remember that if your direction is 45 degrees, okay, below the x-axis, we know x is going to be positive, y will be negative, and we know that for this particular angle, the cosine of the angle and the sine of the angle are going to be exactly the same, right? So if we have, cosine negative pi over 4, okay, that's equal to that number, and the sine of negative pi over 4, okay, it's the same number except it's negative, right? So the magnitude of the number is the same, but we see that the sign is reversed. So therefore, we can pick any number that we please, right? As long as both numbers have the same magnitude and the x value is positive and the y value is negative. So my vector is going to be equal to, let's say, I don't know, 10, negative 10. Okay, fine, right? And the length of my vector is going to be norm vector 2. Okay, and that's the same thing as doing this. Control 2, 10, control 6 squared, plus negative 10, control 6 squared. Shift enter. It's the same thing as just using the norm command here. Excuse me. It's just a little bit less typing. It's easier if you use the norm command. Okay, your choice. Or you can do it this way if you are uncomfortable using the norm command. But this is actually what the norm command does, assuming, of course, that the second argument is 2, right? Okay, so then the unit vector is simply going to be the vector divided by the length. Wow, guess what? It's what we have up here, right? Cosine, cosine negative pi over 4 is 1 over the square root of 2, and sine negative pi over 4 is negative 1 over the square root of 2. Okay, so that's exactly what we have right here. It's the unit vector. And you would have the same answer if this was 1,000, negative 1,000, a million, negative million, etc. Okay, so there you have it. Okay, so that's my unit vector, and then we have to multiply by 92. So answer vector is going to be 92 times the unit vector, and that's going to be 46 times the square root of 2 in the x direction, and then negative 46 times the square root of 2 in the y direction. Okay, so that's going to be 46 square root of 2, and then negative 46 square root of 2, and let's check the answer, and that looks great. Okay? Okay, so here's another. This question, the thing I don't like about it is that, you really need a magnifier because I don't really care for the picture too much. But I do actually have a built-in magnifier in my computer. Well, all Mac computers have a built-in magnifier, actually. Okay, refer to the figure to the right and carry out the following vector operation. Write the vector hi as a scalar multiple of u or v. Okay, hold on one second. So where is hi? Okay, we can see that hi is going to be a multiple of vector v, but it's going in the opposite direction of vector v. Now vector v is going in this direction and hi is going in the opposite direction, and it looks to be about twice as long as vector v, right? So here, let me turn off my magnifier. The answer is simply going to be negative 2v. Okay, so now we have a similar question. Refer to the figure to the right and carry out the following vector operation. Write the vector OG as a sum of scalar multiples of u and v. Okay, let's turn on the magnifier again. So where is OG? Excuse me. Okay, so we can see, excuse me, I'm losing my voice here. We can see this is the vector OG. This is the vector OG. And we can see that OG, well, we have to think, how would we extend u and v? How would we change vectors u and v in order to create the vector OG. So first of all, I would take u and put it in the opposite direction and multiply by 2. That's going to be negative 2u plus 3v. Negative 2u, that's this vector right here, and then 3v is this vector right here. So 3v minus 2u. So 3v minus 2u, and that's going to give us vector OG. Okay? Okay, now for this, excuse me, kind of have a sore throat here. So for this particular problem, we're really going to use Mathematica very extensively. Define the points P is at the origin, 0, 0, and Q is at -4, -5. Okay? For the vector PQ, do the following. Sketch the vector in an XY coordinate system. That's part A. Part B, compute the magnitude of the vector. Now, I'm pretty sure, we know that the point -4, -5 is in quadrant 3 of the XY plane. So we know, excuse me, we know then that this has to be the right picture. None of the other pictures make any sense. However, let's do this picture using Mathematica first, just to make sure. And it'll also give me an opportunity to show you a little bit about using the software, which I think will be very helpful to you. Okay, so let's get started. The first thing I'm going to do is let's graph the XY plane from x is -10 to +10 and y is -10 to +10. All right, so to do that, I'm going to do this in Mathematica. Okay, plot nothing. I'm not graphing any function. I'm going to pick a variable. Everyone loves x, but use whatever variable you want to use. From -10 to +10. Plot range. Well, we know that x goes from -10 to +10, and y will go, the vertical axis. The vertical axis will go from -10 to +10. Okay. I do want to see those tick marks. I definitely want to see the tick marks. So ticks, actually here, let me do it this way. Table, K goes from -10 to +10, and those are the x ticks. Now if you're curious, if you don't understand what table is doing, this is what table is doing. So table, I want all the integers from -10 to +10. Okay, that's what table does. Give me all the integers, let's say, from -10 to +10. And does this letter have to be K? No, it doesn't have to be K. It could be any letter that you want it to be. It could be A, B, C, X, Y, Z. I like K, just because. Okay, and then we'll do the same thing here. K goes from -10 to +10. And hold on, let me pause this video 1 second. There's a lot of noise going on in my house. Hold on a second. Pause. Okay, so let's, okay, ticks, let's see. An aspect, okay, so let's see what we have so far. Okay, it doesn't look too bad. However, I noticed the y-axis is shorter than the x-axis. So I'm going to change that with aspect ratio 1, which means that the y-axis will have the same length as the x-axis. And that's what that's going to look like. And grid lines, let's see. Okay, I don't know why I'm not, okay, so let me do the same thing that I did for the ticks. Let's see, table, and k will go from -10 to 10, and, oops, sorry about that, table, k will go from -10 to 10. Let's see what that looks like. Okay, and that looks pretty good. All right, that looks pretty good so far, right? So we have the background. This generated the background. So the next step is I want to draw the arrow. I want to draw the arrow, and that's going to go from the origin to the point -4, -5. Let me expand this a little bit. So comma, enter, go to the next line, graphics, arrowheads, and I want a big arrowhead. Let's say it's going to be 15% of the width of my graph. An arrow goes from the origin to -4, -5. Okay. And I'm going to include, 1 second. Okay, I'm going to include specifications. I want the color to be black, and I want it to be pretty thick. Absolute thickness, how about 4? I think that'll look pretty good. And if I'm combining 2 pictures, I need to use the show command. Show. Because I'm actually combining 2 pictures. Shift, enter. Okay, there we go. We could make this a little, the arrow's maybe a little too, the arrowhead is actually a little too big. Maybe just 10% of the width of the graph. That looks nice, okay? And let's see what we have. So we can see from the picture, let me compromise. I'll change this to 0.125. There we go. Nah, it looked better the other way. How about, there we go. That's nice. Okay, so what we have here is actually a reproduction of these pictures. And actually, I could also add labels. I could add labels. So axes, labels. Axes label, X and Y, and then label style, that's a directive. Font size is, let's say, 14. Font color is, let's say, black. Font weight is, let's say, bold. And font family, use whatever you want to use. I happen to like Arial. Oh, wait a minute, why didn't that? There we go. Should work. Okay. Well, but then it changed. Hold on 1 second. This actually changed the ticks. The tick style changed, and I'm not crazy about that. So what we could do, we could also put in here tick style directive font weight is normal. And that looks a little bit better. And actually, we could also do font size, make it smaller. How about 12? Yeah, that definitely looks a little bit better. I mean, so there are different things you can do. You can adjust your graph in a lot of different ways, right? So this is the same picture. I realize it's a lot to learn in one lesson. I don't expect you guys to master Mathematica in just a week, but I do expect you to be pretty good at using the software by the end of the course. And it's something that you really should practice. It's something that you should learn because I think it's going to help you in your other STEM classes. STEM, of course, means science, technology, engineering, and mathematics. All right, so this is the picture that we have here. Okay, and we can see it's the same picture that we have here. Okay, it's the exact same. Oh, 1 second, let me make this, shrink that window down a little bit. And this is the same picture that we have here. All right. Oh, 1 second, check answer. And the answer is correct. Okay, one other thing I wanted to show you. This video is getting a little bit long, but one thing, oh, and I'm supposed to figure out the magnitude of the vector. Yeah, I almost forgot to do that. Okay, so we can do that easily enough. So how do we figure out the magnitude? Well, where's my cursor? Here, hold on 1 second. Let me expand this a little bit. Where is my cursor? Okay, and then all right, so my cursor, okay. So my vector, my vector is simply going to be -4, -5. It's actually -4 minus 0, -5 minus 0, but that's the same as -4, -5. So that's my vector, right? The norm of the vector, the 2 norm, it's called the 2 norm of the vector, is the square root of 41. Or I could do it this way. I could do -4 squared, or control 6 squared, plus -5 control 6 squared, and shift enter, and that also gives me the square root of 41. And this is the square root of 41. Whoops, I forgot my square root. Square root of 41. And let's see. Check answer. Okay. Okay, so we just have time for a couple more problems. I would like to do a couple of problems where we have to figure out a plane, the equation of a plane given 3 points. And I believe that's much later on in your homework. Okay, so I think it's in the 60s or 70s. I can always put that into your next video, which I'll make in a few days. Okay, that's not quite what I'm looking for. I'm looking for a very specific type of problem. So, hold on 1 second. And I thought it was in the 60s or 70s. Hold on 1 second, maybe 78. Okay, we can take a look at this problem too, but I really wanted to do a problem where you have to figure out the equation of a plane given 3 points. So let's take a look at problem number 78. Find an equation or inequality that describes the following object. A sphere with center 2, 3, 1, x is 2, y is 3, z is 1, and radius the square root of 15. So this is going to be, well, if it's a, let me think about this a moment. Is this a solid sphere or just a sphere? If it's a, okay, hold on 1 second. So x minus 2 squared plus y minus 3 squared, hold on 1 second, plus z minus 1 squared, okay, is equal to the square root of 15 squared, which is 15. Now the problem is, if this is a solid sphere, if it's a ball, then this would actually be less than or equal to 15. If it's just the surface of the sphere, then it will be equal to 15. I think they only want the surface of the sphere and not all the points inside the sphere. Let's see. Okay, so they just want the surface of the sphere. Okay, however, I'm really looking for a different type of question. Oh, I see. This is the ball where they want the points inside the sphere. Okay, so find an equation or inequality that describes the following object. A solid sphere, which is a ball, with center x is 9, y is -8, and z is -1, with radius 1. So this is going to be x minus 9 squared plus y minus a minus 8, which is y plus 8 squared, plus z minus a minus 1, which is z plus 1 squared, less than or equal to 1. That's going to be option C. And I'm still trying to find that other question, but that's okay. It may not be in this particular homework assignment. Okay, I will show it to you anyway. I'm not sure if it's in your homework. This is going to be the last thing we do in the video, okay? So let's say here. Let me just here. You know what? I'm gonna actually close this window because we're not going to use it. Let's say I want to find the plane that contains. Actually, you know what? Let me put this inside a text box because I think it's going to look a little bit nicer. So palettes. Writing assistant, text cell, and background, let's say, I don't know, light green, and frame, and let's say, well, here, I think I have to start writing first. So let's say, okay, so we're going to make that bold and big. And there we go. So here's the question. Okay, here's my question. Question for 252 students. Question for math 252 students. That's you guys, in case you forgot. So let's say I want to find the equation of the plane that contains the points, and I'm just going to make up any points in three-dimensional space. 4, 3, 1. 4, 2, 1. And 10, 1, 23. What is the equation of the plane that contains those 3 points? Okay. What is the equation of the plane that contains those 3 points? So a nice, easy way of doing this, well, we have to make sure x, y, and z are not defined. Okay, let's say x is equal to 5, y is equal to 6, z is equal to 18. Okay, I have to make sure that I clear those values. Clear x, y, z. Okay, I don't want those values to contain, I don't want those symbols. X, Y, and Z are symbols. I don't want those symbols to contain numeric values. Okay, what is X? X is a symbol. If I do this, right, what is X? X is now an integer, and that's bad, right? I don't want that in order to figure out this problem. Okay, so clear X. And now I can see that X is back to being a symbol. Okay, so I'm going to put my cursor up here, and here's what I'm going to do. My matrix, or call it whatever you want to call it, x minus 4, I'm looking at the first point, by the way, y minus 3, z minus 1. Okay. X minus 4, y minus 2, z minus 1. And finally, x minus 10, y minus 1, and z minus 23. I need that semicolon. You need a semicolon if you're going to put two or more commands together, like, on the same line or in the same command sequence. My matrix form. Let me make that look a little prettier. Traditional form. Okay, so this is the matrix. And by the way, I really do need that semicolon. Either that or just do this part on a separate line. But if you put them together into the same command, you need that semicolon, otherwise you're going to have problems. Okay, every matrix has a special number called a determinant. Every matrix has a special number called, let me change that statement. Every square matrix has a special number called a determinant. This is a square matrix because it has 3 rows and 3 columns. The number of rows is the same as the number of columns, therefore it is a square matrix. This is a square matrix, okay? Right? Every square matrix has a determinant. So for this problem, what is my determinant? Determinant is, okay, this is my determinant. This is my determinant right over here. This is my determinant. 82 minus 22x plus 6z, and the y's got canceled out. The y's got canceled out, and that's perfectly okay. So the equation of this plane, is going to be equation, well, I could solve this for z, right? Solve det is equal to 0, and there's a complicated reason for this. It's a little bit hard to explain, but when I'm in three-dimensional space, okay, what I have here, I have 3 points that describe a plane. If I'm dealing with a solid rectangular region, if this region, the region described by the 3 points, if it's a prism, a rectangular prism, the determinant will be non-zero. If it's a plane, if it's completely flattened into 2 dimensions, then the determinant has to be 0. Okay? And I want to find, let's see, I'm going to solve that for z. And let's do a little algebra on that. Expand. Okay, so I can see here that z of x is equal to negative 41 over 3 plus 11 times x, the space, I could do this, times x, or space x, over 3. Okay, now y got thrown away. Y actually, interestingly, y got thrown away. Which is really interesting that y got tossed out like that. And I think, whoa. Okay, so Yeah, so y, this is kind of a weird example. Let me give you an example where y does not get tossed out, because this is a little bit confusing, because what we really have here is it's really more of the equation. Well, it is the equation of a plane, but the y part got tossed away. So let me change this to, how about -3? Let me make that -3. So y minus a -3 is a +3. Okay. And let's change that. Determinant. It's very strange that y... What is my value of y? Head y should be a symbol. Okay, so I'm not picking very good points here. So, okay, let me change that again. Let me make this a -4. Let me make that a -4. So this will become x minus a -4. That will be x plus 4. Okay, so I'm changing this again. There we go. Now I have my y. Okay, yeah, that was interesting. So the y value was getting discarded, and it's not quite what I wanted. So these are my points: 4, -3, 1, -4, 2, 1, and 10, 1, 23. So x minus 4, y minus a -3, which is y plus 3, z minus 1, x minus a -4, which is the same as x plus 4, y minus 2, z minus 1, x minus 10, y minus 1, z minus 23. So now, okay, so now I have z. Let me define my function. Z of x and y is equal to 75 over 31 plus 55 times x over 31 plus 88 times y over 31. Now let's see if that actually works. Okay, these are my points. These are my points right over here. Let me do a copy and paste. Oh, that's going to be a little tricky. Hold on one second. Let me do a copy and paste. And 10, 1, 23. Okay, those are my points. So if x is 4 and y is -3, I should have 1. If x is -4 and y is 2, I should have 1. And if x is 10 and y is 1, I should have 23. Okay, so that's a really, in my opinion, it's a really good way to figure out the equation of a plane if you're given 3 points in that plane. Okay? Okay, this video has gotten long enough. Hopefully you've learned something about vectors, and hopefully you've learned something about Mathematica. And I think we are done for today. Okay, great lecture, I hope. Take care and have a great day. Bye-bye.